says the radius of a circle is increasing. So I'm talking about the radius. Is increasing. At a certain instant, the rate of increase in the area of the circle, keyword is rate. So right there they're talking about dAdt. The rate of increase in the area. So I could cross all of this off, and it's all talking about dAdt. Is numerically equal to twice the rate of increase of the circumference. That's dcdt. So I could cross all of this off. I could write an equation now. The rate of increase of the area, dAdt, is twice the rate of increase of the circumference. So as long as I'm writing, I know I'm making progress. I keep going. Question? Well, what is the radius of the circle at that instant? Okay, because they're talking about how rates relate to each other, I recognize this as a related rate problem. So I think of the DREAD algorithm. Oh, yeah. So I'm like, okay, good. So we got to have a mountain rate here. So we've got dAdt. That means we've got to worry about A. We've got dcdt. That means we have to worry about C. They also talk about the radius, and the fact that the radius is increasing. So that would be R and drdt. So now I've done this step here. I've got my Danikus chart. I've also written down all the rates that I read about in the problem. Questions? Well, next step is to create an equation that uses all the amounts. Okay, I kind of look over here. In some ways, the word DREAD is a good, bad thing. Like, it's good in that it kind of helps get you moving on the problem. It's bad in that you lose track of the big idea. The big idea of this problem is, if I can get an equation that shows how the amounts are associated, I can differentiate that equation and see how the rates are associated. That's the whole idea of a related rate problem. So the whole focus is to get this equation. This is the big idea. Well, there's not one equation that relates those two amounts here. There's two equations, the two main equations that deal with circles. We need a little more space here, so let's copy this page, let's get a new page. So the two equations are circumference is equal to 2 pi r, and area is equal to pi r squared. Question. So, last step in the DREAD process is to differentiate both sides of that equation. So I apply the ddt operator, both sides. Question. Keep going. anything bothering anyone? Cool. Okay, we're done with the dread process. Now we just got to look at the clues in the problem and figure out how this is how all dread problems work. I get this equation, or in this case equations. Somehow those new equations will help me answer the question given in the problem. So somehow these two things are supposed to help me figure out how to find the radius at this magic moment when the, what was it? It said the ADT was the same as 2 times dc dt. So raise your hand if you know what I should do next. I've said all year long that this class is all about being really good with the equal sign. Can you see what is equal to what? If you can, then you're all set. This class is, unbeknownst to many, is really good preparation for being a lawyer. No, really, being a lawyer is all about saying, if this is true, then this must be true. That's what it's all about, like thinking logically. So what do we do now? Hands, come on. More here. Let's go Miles.
You would take the equation from the put it into
Say it louder.
yeah, you took that and put it into the equation I gave you from the problem. Yeah.
So I take this, put it right here. That's got to equal 2 times that. How many saw 0.2 per mile? Do you want me to talk more about it? Now what? Oh, Eric, question. You see it? If you don't see it, it's fine. I'll just show more. You see it?
I don't really see it.
No worries. Are you okay with this?
Yeah.
Okay. If this doesn't help, you just tell me it doesn't help and I'll take a different approach. But I like to think of equal as like playing with blocks. I'm going to take this block right here. That black one, that's this one. Because they're the same thing. So I'm going to take that block out and I'm going to put that block in its place. So that's what I did here. You see that? You see that okay?
Yeah.
Cool. Then I'm going to take this blue block right here. Which is the same as this blue block right there. And I'm going to swap those. So that's this one. So that's how I get that equation. There we go. Raise your hand, please. You got to think with me. You can't watch. What's the goal of the problem? Like, don't lose track of that. You do something, you got to remind yourself, what am I trying to do? For hands? Paul?
Find the radius.
So what do you do?
So we find dr dt.
I'm trying to solve for this. There's 2 ways to solve this problem. One, just look at it and write down the answer. I'm not kidding. Like, if these two are to be equal, raise your hand, you can see it. What value must R have? If those are going to be equal. Equal means the same. Equal's not like we do this, then we do this. Equal means these are the same. So what's R got to be? And you can see it, I think. What is it?
2.
2. How many saw it? 2 points. 3 for Emmy. Question. Please.
Let's say though that it wasn't really obvious. How do you figure out, 'cause I see a variable at DRDT and at R, so how do you solve for that?
No, really good question, 2 points. Trying to get the R alone, so you can do it. Just tell me what you would naturally think to do if you were trying to get the R alone.
Well, I first divide out all those other numbers, so 2 and pi DRDT.
So divide both sides by 2.
2 pi.
2 pi, what would that give you? What's the new equation?
R DRDT equals, and would it be easier to multiply the 2 over the parentheses first?
So remember this sign here from Amanda. Like, it really helps to always keep track of terms versus factors. So does this expression consist of terms, factors, or both?
Only factors.
Only factors. That means we really don't need the parentheses.
Oh, okay.
The only purpose for the parenthesis is so you don't think that it's 22. Otherwise, the parenthesis is doing nothing.
So you could just say 4 pi.
Uh-huh.
Okay.
Does that make sense?
Yeah, that's it.
Yeah. So when I divide it, what's this side going to be, David?
Then it's going to be that 4 pi DRDT over.
Oh, so we divided both sides by 2 pi. remember?
Oh, so you can just get rid of the 2 pi. It's
So
gonna
what's
be
left?
2 DRDT.
There we go.
And then the DRDT can
Divide out.
Divide out.
Does that make sense? 2 more. There we go. There we go. Just brought them. Look, huge key to this class, I've been saying it since day 1, is you gotta learn what it means to understand something, not what it learns to copy someone. Like it's just everywhere. Like in our world, you cannot succeed any longer by copying. Like you have to understand. I have I don't know, kind of a hobby, I guess. It's I'm trying to help my kids with their cars. So I find it very interesting to learn how cars work and how to fix them and that sort of thing. So I watch lots of YouTube videos on people explaining how to diagnose automotive problems. They go to the same place. They're like, you can't just swap parts and hope it works anymore. You've got to understand how the part works so you can figure out which part you really do need to change. That sort of idea. Same thing. So it's no different. Question. If we have a different question, then we can talk about